Hello, my name is Brian and welcome to another video on sketching piecewise defined functions. So let's go ahead and take a look at this function. It is actually a pretty complicated one that you'll probably see in class. It has four pieces. You have the x plus 1 squared minus 1, which is a transformation of x squared. You have 2, negative 2x plus 3, and then the square root of x. Now, before getting started, the number one thing when graphing piecewise defined function is that you can graph each individual one on its own. So, for example, can you graph x plus 1 squared minus 1 on its own? Now, if you do it correctly, what you'll find is that it looks like this parabola. It's the normal x squared, but it's been shifted to the left 1 and then down 1. And that's how we get this right here. All right, the next one is the point negative 1, 2, all right, which is just a coordinate point at negative 1, 2. Then our third piece, which is negative 2x plus 3, all right, that's going to look like this line right here. And again, if you're not sure how to graph lines, what you can do is you can make a little t-table and pick 3 different x values, something like that. And then if you were to plug 0 in to here, you'd get 3. So you plot the point 0, 3. If you plug in 1, you get negative 2 plus 3. That's a positive 1. So that would be at the point 1, 1. And finally, if you plug in negative 1, you get negative 2 times negative 1. It's positive 2 plus 3 is 5. And so that would be at negative 1, 5. And then you'd connect the dots and you'd have the graph. The third graph is the square root of x, which is actually, it's one of our basic functions, so you don't really need to, you should just memorize that one. Okay, so let's get started. So here's our big defined piecewise function again. We're going to start with x squared, the x plus 1 squared minus 1. What we're going to do is we're going to figure out what this is supposed to look like on its respective domain when x is less than negative 1. So if you go to negative 1, notice that it does not have an equal sign here. Okay, no equal sign, which means when you go to negative 1 and you plot that point, it should be an open dot. Now what we're going to do is we're going to erase everything on this side, and we're going to keep everything over here. And if we do this correctly, this is what we would get. Now that we're done with this one, I'm just going to place that graph over here. This is going to be our final graph. And so every time I figure out a piece that goes on the final graph, I'm going to put it over here. All right, let's move on to the next one. This point negative 1, 2. All I'm going to do is actually just plot that point negative 1, 2, which is going to go here. Okay, and I did it over here as well. All right, third, negative 2x plus 3. We already know how to graph that. So there's my graph. Now, it's supposed to look like this line from negative 1 to 1. So here's negative 1. Here's 1. Notice that I do not have an equal sign on the inequalities, which means when I plot negative 1, I'm going to get an open dot. And when I plot positive 1, I'm going to get an open dot. And I'm supposed to look like negative 2x plus 3 in between these two x values. So in here, I'm supposed to darken in that line and keep it, and I'm supposed to erase everything on the outside. Now, if you do that correctly, you get this, and now I'm going to place that over onto our final graph. Our final piece is the square root of x, which, is going to, it's a regular square root of x function, so it should look something like this, right? But notice that I am starting at 1, and I get to include 1. So that means I'm going to put a closed dot at 1. I'm going to keep all of this. I'm going to erase that piece because that's the left of 1 and I don't want it. And that's what I get over here. So this is my final answer. Let's go ahead and put that in the middle here. I kept this green. I think that's green. But if you're doing this, this would all be one solid color unless you're using colored pencils. So here's another example. It's a bit complicated, especially this right here. You need to figure out what that means. But for the solution to this suggested problem and more information about the school I work at, NIU, please visit the following link found below.